Hi, and welcome to this section of the Algebra Word Problem Tutor. And it's kind of funny that this is called the Algebra Word Problem Tutor, but this section of the course is actually going to deal with word problems involving geometry. And I kind of struggled where to put this, if I should put this particular section in the geometry course or not, but I felt like in the end it fit more with the word problems and the theme of algebra, because you'll see that when we work the problems, even though they involve geometry and geometric concepts, when you actually solve them, you're doing a lot of algebra. You're setting up algebra equations, basically, to solve what you're trying to solve for. We're just going to use some of the concepts in geometry that I know you're all familiar with, and if you're not familiar with them, I'm going to teach you them as we go along. Here in the class. So the idea here is the same as the other ones. We're going to read the problem. We're going to set up in many cases a diagram, but we'll also set up our equations and we'll solve our equations and we'll get the answers. So let's just dive right into it. The first one says the perimeter of a rectangle is 42 inches and the length of the rectangle is 3 inches longer than the width. Find the dimensions of the rectangle. So the only thing that I really need to point out here that you may or may not know is the perimeter of something just means how far all the way around the bases there would it be. So if you measure with a tape measure all the way around, that would be called the perimeter. So it says the perimeter of a rectangle is 42 inches. So before we get into that, let's just draw a rectangle. Okay? We know it has some width and we know it has some length. Okay? And this width here is the same as this width, and this length is the same as this length because it's a rectangle. Okay? Now, we know that the perimeter of a rectangle is going to be equal to the total length all the way around, okay, which is 2L plus 2W. Now, if you don't quite see that or remember that from geometry, it kind of makes sense. It's the total length all the way around. So 2 times L is going to be this plus this, and 2 times W is this plus this. So if I add all of this together, that gives me the perimeter. But it tells me in the problem that the perimeter is equal to 42. So that's going to be 2L plus 2W. This is one of my two equations. This is one of the ones I want to keep to help me solve the problem. The next thing it says is the length is 3 inches longer than the width. L is 3 plus W. The length is 3 inches longer than the width, so that's another important equation. Now notice I'm trying to find the dimensions of this rectangle, which means I'm trying to find the length and the width. Now I've got two equations and two unknowns, and that's exactly what I need to solve the problem. So let's proceed just as we have before. Let's take this L and we'll plug it into here. So what we will get is 42 is equal to 2 times L, but L is given by this, so I'll put 3 plus W in, plus 2W, just kind of carrying this down. Now I can solve for W. Okay? 42 is equal to, distribute this 2 in, 2 times 3 gives me 6, plus 2 times W gives me 2W. And then, of course, I have this 2W over here that just is along for the ride. Okay? So then 42 is equal to 6 plus 2W plus 2W is 4W. Okay? And now in order to solve for W, I need to get it by itself. So I'm going to take the 6 and I'm going to move it over. So I'm going to have 42 minus 6 because I'm going to subtract 6 from both sides. On the right, it disappears because 6 minus 6 is 0. And on the left, you're just subtracting here. Now 42 minus 6 is 36, okay? And that's equal to 4W. And so W, just divide both sides by 4 to get rid of this. 36 divided by 4, W is equal to 9. That is the width of the rectangle. So I'm halfway home. To find the length, I just use my other equation here that I have. L is equal to 3 plus W. So the length is equal to 3 plus the width, which was 9. So the length is equal to 12. Okay? Length is equal to, width is equal to 9, length is equal to 12. And this is all in inches because the problem was dealing with inches. Okay? So, does the length equal 3 plus the width? Well, sure it does. 3 plus the width gives me my length. And if you were to take these two numbers and put them up into here, you would find that the perimeter all the way around this rectangle is going to be 42 inches. Okay? So it's the same thing that we've been doing before, it's just we have to use some of the principles from geometry when dealing with these kinds of problems. And you'll see these kinds of problems everywhere. You'll see them on any of the standardized tests like the SAT or the GRE, and you'll see them in your homeworks and your exams in class 2. So the next problem is going to deal with angles in terms of angles in a triangle. So it says the sum of the angles in a triangle is 180 degrees. And by the way, that's always true. I'm just giving you this in case you don't know. The sum of the angles in a triangle is always equal to 180, no matter what the shape of the triangle is. That's just a fact, okay? So the sum of the angles in a triangle is 180 degrees. The second angle is 30 degrees more than the first angle. And the third angle is 8 times the first angle. Find the angles in the triangle. So the first thing you need to do is realize that we're talking about a triangle. So we'll just draw a triangle, okay? And I have 3 angles, and it sure would be nice to label them. So I'm going to label them A and B and C. These are the 3 angles in the corner, okay? And it says right here that the sum of the angles is 180 degrees. So that's exactly what I need. A plus B plus C is equal to 180 degrees. A plus B plus C is 180 degrees, okay? The second sentence says the second angle is 30 degrees more than the first one. So I'm going to say that B is the second angle, okay? The second angle, B, is equal to 30 degrees more than the first angle. And then the third sentence says the third angle, which is C, I'm calling the third angle, is 8 times the first angle. So you really just need to write the equations down. Now look, here I have 3 variables, 3 angles, 3 variables, and 3 equations. That's what I need. If you have 2 variables, you always need 2 equations. 3 variables, you need 3 equations. 10 variables, you need 10 equations. That's just the way it works. So, sum of the angles must be equal to 180. Second angle is 30 degrees more than the first angle, and the third angle is 8 times the first angle. So, let's go ahead and plug these values into this top equation. A plus, using this equation, B, but B is simply A plus 30, plus C, but C is given by 8A, is equal to 180. So you see, all I'm doing is using this equation and plugging in for B and plugging in for C. Okay? So A plus 8A is 10A. So A plus 10A is plus 8A is 10A, plus the 30 here is equal to 180. All I've done was add the A's up. Okay? So 10A is equal to 180 minus 30. I subtracted 30 from both sides. It disappears from this side. It becomes 180 minus 30. Okay? So 10A is equal to 150. And then A is just 150 divided by 10. So A is going to equal 15. A is going to equal 15 degrees. Okay? Now to find C and to find B, you just go back and you plug into these equations here. So B is going to be equal to A plus 30. So B is 15 plus 30, which is 45. So B is equal to 45 degrees. Okay? And then C is simply equal to 8 times A. And so C is equal to 8 times 15. And then C, when you take 8 times 15, you get 120 degrees. Okay? So you found your 3 angles. You had your equations. We plugged 2 of the equations into the third one. We solved for A, and then we went back and we plugged A in, and we got B and we got C. And I'll leave it as an exercise to you. If you take 15 plus 45 plus 120, they will add up to 180 degrees, which is what we said the triangle always adds up. Now the next problem says the area of a rectangle is 32 square inches. If one side is twice the length of the other side, what is the perimeter of the rectangle? So I know the area, and I know that one side is twice the length of the other, but I'm trying to find the perimeter, and the perimeter is the distance all the way around the rectangle. So let's do that now. We have a rectangle. I think always, especially when you're dealing with anything that has a shape, it's a really good idea to draw a picture. I mean, I'm not doing this for you, I'm doing this for me. I always do this when I do my own problems. So I highly suggest, even if it's a simple looking rectangle, just go ahead and draw a picture. Now it says the area of the rectangle is 32 square inches. And if you remember back, the area of a rectangle is just simply equal to the product of the lengths of the two sides. So here it's going to be length times width. That is the definition of the area of a rectangle. Okay? So they gave us the area, which was 32 square inches. That is one equation I need to keep. The area of a rectangle is 32 square inches. That's how you write that in words. Okay? It also says the length of one side is equal to 2 times the length of the other side. So that's my other equation. Okay, so now I have two equations and two unknowns, and it's going to let me find the value of L and the value of W, and the perimeter is just adding them all up. Okay, so I'm going to use these equations to find the length and the width, and then I'm going to use that to find the perimeter, which is what the problem actually asked me to do. So plugging this in, 32 is equal to, plugging L in here is 2 times W times W, taking this L and plugging it into there. So 32 is equal to 2W squared. W times W gives me W squared. Okay? Now to get W squared by itself, I'm going to divide both sides by 2. So 32 divided by 2 is equal to W squared. So then W squared is going to be equal to 16. And then in order to get W by itself, I can take the square root of 16, but I have to put a plus or a minus there anytime I take a square root like this. I said that before, and I'll say it again. You have to put a plus or a minus when you take a square root, okay? Because in the end, W can equal 4, or W can equal negative 4, okay? Those are the two widths, okay, that I can have. But mathematically, I have to put a plus or a minus, so I have a negative width and a positive width, but you know from your common sense that you cannot have a negative width of a rectangle, okay? It just can't happen. You always have positive lengths, okay? So even though you mathematically got this negative width, you toss it out because it really just isn't going to happen. It's mathematically, it's a valid part of the equation, but in real life, you cannot have a negative width, okay? So how do we find the length? The length is equal to 2 times the width. 2 times the width. So the length is equal to 2 times 4. So the length is equal to 8. Okay? So now we have the length and the width. The perimeter is equal to 2L plus 2W, just adding everything up. 2 times L plus 2 times W adds everything up all the way around. So the perimeter is equal to 2 times the length, which is 8, plus 2 times the width, which is 4. So the perimeter is equal to 8 times 2 is 16, plus 2 times 4 is 8. 16 plus 8, perimeter is going to equal to 24. And that's 24 inches, because we're dealing with inches in this problem. Okay, the perimeter is 24 inches. So you see, this one was a little bit tricky only because you may not know exactly how to get the perimeter at first. That's what you're trying to find. But you know that the area is length times width, and they give you that. And you know that one side is twice the length of the other, and that allowed us to find the lengths of the sides. And once we found the lengths of the width and the length of the length, then we could just put it into the formula for perimeter, which is just simply adding them up, by the way, all the way around. Then you get your 24. The next problem says the height of a triangle is 8 feet longer than its base. If its area is 10 square feet, find the measure of its base and its height. So we know we have a triangle. We know the height of it, tall, is 8 feet longer than its base. So it's kind of got a narrow base and a tall height there. And we know the area is 10 square feet. So now we're trying to find the base and the height. So again, we have our nice little triangle, okay? And we know we have a base here. And if you remember back from your geometry, this is called the height. It's not this slant height, it's the height totally up and down like this. And the area of a triangle is 1/2 times the base times the height. That's just a fact. That's the area of a triangle. So they tell us that the area is 10 square feet, so we know that 10 is equal to 1/2 times the base times the height. We know what the area is. This is one equation I want to keep. That's one fact that the problem gives us. Now it says the height of a triangle is 8 feet longer than its base. The height is 8 feet longer than its base. So whatever the base is, you add 8 to it, and that's what the height is equal to. So now I have two equations and 2 unknowns, and that's what I need to have. So what I'll do is I'll take this h and I'll plug it into this formula. 10 is equal to 1/2 times the base times the height, but the height is given by 8 plus b. Okay? The next thing I'll do is I'll just carry everything down, but I will distribute this b into the parentheses. b times 8 is 8b. What I'm going to do is I'm going to do it like this. I'm going to leave the 1/2 out like here, and I'm just going to multiply this. b times 8 is 8b, plus b times b is b squared. Okay? So make sure you understand that. This 1/2 is still sitting out here. I'm still multiplying by it, but now what I'm doing is I'm just going to distribute this b in. I'm going to keep it in brackets because I haven't done anything to that 1/2 yet. I'm just trying to keep the steps crystal clear here for you. Okay? I can't add these together. I just can't. Okay? So what I'm going to end up doing in its place, now that I've done this, is I'm just going to distribute this 1/2 in. 1/2 times 8 is 4b, plus 1/2 times b squared is just 1/2 b squared. Can't do anything with that. Okay? And then the next thing I'm going to do is I want to get everything on the same side of the equation. So what I'm going to do is I'm going to move this 10 over here. So I'm going to have 1/2 b squared plus 4b, haven't touched this, minus 10 equals 0. Now make sure you understand that. I subtracted 10 from both sides. Minus 10 gives me 0. Moving it over here gives me a minus 10. And that's just everything down here. The 1/2 b squared, the 4b, minus the 10 gives me 0. Now, I do not like having a 1/2 there. You can still solve this problem with this here, but I just personally don't like fractions in my quadratic, functions like this. So I want to get rid of this. So I want to multiply this entire equation by 2. I'm going to multiply everything on the left by 2, and I'm going to multiply everything on the right by 2. So when I do that, when I multiply everything by 2, I'm going to have 1/2 times 2 is just simply 1, so I'm going to have b squared plus 4 times 2 is 8b minus 10 times 2 is 20, and on the right I still have to multiply by 2, but 0 times 2 is 0. So make sure you understand what's happening here. I took this equation, I multiplied it by 2. I did that only because I wanted to get rid of this fraction. 2 times 1/2 gives me 1, 2 times 4 gives me 8, 2 times negative 10 gives me negative 20, 2 times 0 gives me 0. It's legal as long as I do the same thing to both sides of this equal sign. Okay? And now it looks like it's in a whole lot more friendly form to factor. Again, you could have worked some magic here, but this is a lot more friendly to look at. So I'm going to put my b here and my b here, because I know I'm going to multiply to get b squared. And now I've got to pick two numbers that multiply together to give me 20. And I know right off the bat that 10 times 2 is going to give me 20. And I'm going to choose my signs so that I have a plus here and a minus here. And I've gone through my mental calculation to figure out why I want to do this, and you might have to play around with it yourself, which one needs to be positive, which one needs to be negative. But I say let's just check it and see if we're right, and that's what you should do. Check it, see if you're right, and if you're wrong, play with it again. B times b gives you b squared, okay? Plus 10 times b gives you 10b, minus 2 times b gives you 2b, and then the two last ones is negative 20. So b squared plus 8b, because these two added together give you 8b minus 20. That's what I'm trying to achieve, okay? What I'm trying to say is that choosing these signs and factoring this expression is a little bit of a trial and error thing, and I've got a lot of practice with it. And if you don't, just pick your numbers, b and b, pick your two numbers to multiply, and play around with these signs. I mean, if I put a negative here and a positive here, then you would get the wrong answer by checking yourself, and then you would know that that was wrong, and you'd go back and pick something else. But now that we've done it, this is equal to 0, and this is also equal to 0, because either one of these terms multiplied by 0 is going to equal the 0 over here. So b plus 10 is equal to 0, and b minus 2 is equal to 0. Okay? So this says that b is equal to negative 10, okay? And this says that b is equal to positive 2. I subtracted 10 from both sides, giving me negative 10, and I added 2 to both sides, giving me 2. Now don't forget what we're trying to do here. We're trying to calculate the base and the height of a triangle. The base calculated here is negative 10, and the base calculated here is positive 2. This negative 10 cannot happen. You cannot have a negative length. You cannot have a negative length of anything. If you get a negative length, it's mathematically right. It's a mathematically valid solution, but it's not real life, okay? So you throw it out, okay? So the only one that we really have is b is equal to 2, and to find h, you go back up to your equation for h. H is equal to 8 plus b, which is equal to 8 plus 2, so h is equal to 10. So h was equal to 10, and b is equal to 2. And let's just check our work and see if we're right. First, is the height 8 more than the base? Yes, the height is 10, it's 8 more than the base, yes. And let's now calculate the area. 1/2 base times height. Base times height, 10 times 2 is 20. 1/2 of that is 10. So we have calculated the numbers right to give us the right area there. Okay, and the final problem in this section goes like this. If the area of a circle is 9 pi, what is its circumference? It's a very short problem. If the area of a circle is 9 pi, what is its circumference? So in order to do this, you have to know a few things about geometry. The area of a circle is simply equal to pi times r squared. Okay? The circumference of a circle is equal to 2 times pi times r, where r is the radius of a circle. It's just the distance from the center to the edge. That's all radius means. So the area was pi r squared, and we said the area is equal to 9 times pi. So plugging that in here, 9 pi is equal to pi r squared. Okay? Well, we notice right away that I've got pi on the left and pi on the right, so these pi's can cancel, because I can divide both sides of this equation by pi. Pi divided by pi is 1, pi divided by pi is 1, and so they just disappear. So what you have is 9 is equal to r squared. And if I wanted to solve for r would equal plus minus the square root of 9. Okay, I have to have the plus or minus because I'm applying a square root, and I have to do that because there's always two solutions to a term that has a square like this. So r would be equal to positive 3, square root of 9 is 3. R would be equal to negative 3. But, just like we said before, we're dealing with a distance. That's what the radius is. So this negative 3 doesn't make physical sense, so you can throw it out. It's a valid solution mathematically, but real life, you cannot have a negative distance. Okay? So, knowing this, now we have calculated the radius, and we're trying to find out what the circumference is. So the circumference is 2 pi r. Okay? 2 pi times r, which is the radius, 3. C is equal to 2 times 3 is 6 pi. 6 pi. And that is the answer, 6 pi. Now you can take pi equal 3.14, multiply by 6, and you'll get some answer, that's fine. Or you can just leave it in terms of pi, and that's fine too. So this was somewhat of a simple problem. You were given the area, and you had to find the radius, and then use that to find the circumference. So this section's kind of been a hodgepodge a little bit. It's been dealing with word problems that involve geometric type concepts, different parts of geometry, the angles on a triangle, perimeter, area, circles, things like that. But in the end, they all involve algebra to solve them, and that's why I put them in this course. In real life, you're gonna have to apply different things that you know, okay, in order to solve the problem. You may be working on a rocket ship or a spacecraft, or you may be designing a building, or you may be building a bridge or whatever, and you're not going to go always back to your bridge building book to find the answers. You might need to know how to calculate the surface area of the concrete you're trying to pour into your bridge. You might need to know how to calculate the area or something, or the volume. You might need to know how much concrete to pour into your pillars to build your bridge. You have to calculate the volume of the column or whatever it is you're trying to do. And those things aren't going to be in your book for building bridges. Those are going to be in your head from way back when in geometry and other parts of your life when you've learned different things. So that's kind of what this section's been about. It's been about using some knowledge that we've gained in other classes and applying our knowledge of word problems and trying to extract and write the equations and solve the problems. And that's how we did that for these word problems that involve geometry.